Good morning to everyone. In this class, we are going to discuss problems in mathematical induction. Okay, so as a principle of mathematical induction. So here, so, let P of n be a statement or proposition involving the natural number n. Then, if P of 1 is true, and uh, and if P of k plus 1 is true on the assumption that P of k is true. So here, usually we'll take the given statement is P of n, and we will we will prove the statement for n equal to what 1. Okay, n equal to 1. We will prove the statement is true, and assume the statement is true for what n equal to k. So for n equal to k, we are assuming the statement is true. Here for n equal to 1, we need to prove. For n equal to k, we should take the statement is, we are assuming the statement is what? True. And for n equal to k plus 1, that is p of k plus 1, is again we need to prove it is what? True. We need to prove this one. This is the idea. Now, uh, first, first there are two steps. Okay, first one, we must prove P of 1 is true. Second step, assuming that P of k is true, and we must prove that P of k plus 1 is also true. The first step is called basis step of the proof. So this one is called the basis step of the proof. The second step is called the induction step of the proof. Okay. So next problem. So here you have a problem. Okay, I explained this problem in the another PDF. This one. Okay, maybe I will show you. Summation I equal to 1 to n square equal to 1 to n k square is equal to what? N into n plus 1 into 2n plus 1 by 6. I think I explained this here. Okay. Okay. So now prove by mathematical induction that for n greater than or equal to 1 square plus 2 square plus up to what n square is equal to n into n plus 1 into 2n plus 1 by 6. So I will take the given statement is P of n equal to the given statement. Okay, now let us take n equal to 1. So we need to prove the statement is true for what? N equal to 1. That means in the left hand side substitute n equal to 1. The left hand side of P of 1 is what? 1 square equal to 1. Similarly, the right hand side substitute n equal to 1. So 1 into 2 into what? 3 by 6. So 1 into 2 into 3 by 6 is what? 6 by 6, 1. So both left hand side and right hand side of P of 1 is what? Same. So therefore P of 1 is what? 2. So let us assume that the statement is true for what? P of k. So that means what is P of k? 1 square plus 2 square up to what? K square is equal to k into k plus 1 into 2k plus 1 by 6 is true. Now, our claim is P of k plus 1 is also true. That is, we need to prove what? 1 square plus 2 square up to what? K plus 1 whole square is equal to, okay, substitute n equal to what? K plus 1. Substitute n equal to k plus 1 here. Okay, in P of n, you will get what? If you substitute k plus 1. K plus 1 into k plus 2 into, okay, so n equal to k plus 1 means 2k plus 2 in 2k plus 1, 2k plus 2 plus 1, 2k plus 3. Okay, 2k plus 3. Okay, substitute n equal to k plus 1 in p of k plus 1, in p of n. Okay, so we need, this is our claim. Now take the left hand side. What is the left hand side? 1 square plus 2 square plus k square up to k plus 1 whole square. Now I'm going to write this one, 1 square to what? K square plus k plus 1 whole square. By mathematical induction, what is this value already? We know that 1 plus 1 square plus 1 square to 2 square plus up to k square is what? K into k plus 1 into 2k plus 1 by 6. So instead of this term, I'm replacing by k into k plus 1 into 2k plus 1 by 6 plus k plus 1 whole square. Now I'll take the 6 is LCM from here to here. From here to here, I'll take commonly what? K plus 1. So remaining is what? K into 2k plus 1 plus 6 into k plus 1 by 6. So k plus 1 into 2k square plus k plus 6k plus 6 by 6. So k plus 1 into 2k square plus 7k plus 6 by 6, or k plus 1 into, I'm going to factorize this one, 2k square plus, if you multiply two numbers, you'll get what? 12. 2 into 6, 12. If you add the two numbers, you'll get what? 7 means 4 and 3. Okay, so 4k plus 3k. I'll split the 7k. Okay, plus 6 whole divided by 6. So k plus 1 into, from this take commonly what? 2k into what? K plus 2 plus 3 into k plus 2 by 6. So k plus 1. Here what is common? K plus 2 is common. So remaining is what? 2k plus 3 whole divided by 6. So and hence we proved p of k plus 1 is true. So thus if p of k is true, that is our assumption. Okay, p of k plus 1 is also true. So therefore by principle of mathematical induction, 1 square plus 2 square plus up to n square equal to n into n plus 1 into 2n plus 1 by 6 is true for all n greater than or equal to 1. Okay. So the next problem, show that a power n minus b power n is divisible by what? A minus b for all n greater than or n belongs to capital N. Okay, I think this problem is also here. Also, I have this problem. Okay. Maybe. Yeah. Show that a power n minus b power n is divisible by a minus b for all n belongs to capital N. So let us take p of n. What is p of n? P of n is a power n minus b power n is divisible by a minus b. Okay. Yes. So I'll took p of n is a power n minus b power n is divisible by a minus b. Put n equal to 1. So n equal to 1 means p of 1 is what? A power 1 minus b power 1. That is equal to a minus b. So we know that a minus b is what? Divisible by a minus b. So and hence the statement is true for n equal to 1. Assume the statement is true for n equal to k. That is p of k is true. So what do you mean by p of k is true? A power k minus b power k is what? Divisible by a minus b. A minus b. Okay. So what is the meaning of a power k minus b power k is divisible by a minus b? Okay. So uh, actually, if you divide a power k minus b power k by a minus b, you'll get some constant. So that's why I'll take, let a power k minus b power k equal to some c into a minus b. Okay. Now from this a power k equal to b power k plus c into a minus b. Okay. Now a power k is equal to b power k plus c into what? A minus b. Yeah. Next step. Okay. I think this is the last step in this slide. Okay. Next. Now I am going to check whether p of k plus 1 is true. Okay. What is p of k plus 1? P of k plus 1 is nothing but we need to prove what? A power k plus 1 minus b power k plus 1 is divisible by what? A minus b. That is, I want to show that. So that's why I'll take what? A power k plus 1 minus b power k plus 1 is equal to a into a power k minus b into what? B power k. What is a power k from the previous step? A power k equal to what? B power k plus c into what? A minus b. So instead of a power k, I will replace this expression in the next slide. So I replaced by this expression b power k, a power k equal to b power k plus c into a minus b, minus b into what? B power k. So now multiply a into b power k plus ac into a minus b minus b into b power k. So in these two terms, b power k is common. So a minus b into what? B power k plus ac into a minus b. Here what is common? A minus b is common. So if I take a minus b, what is remaining? B power k plus ac. So from this, what you will get? A power k plus 1 minus b power k plus 1 is equal to a minus b into b power k plus ac. This implies or therefore a power k plus 1 minus b power k plus 1 is what? Divisible by a minus c. So okay, so that is we proved, and then one more step if you want you can write. Okay, so therefore a power what is the last step? I told this is the last step. Therefore a power k plus 1 minus b power k plus 1 is what? Divisible by a minus b, and then we can write. Therefore, if that is if p of k is true, p of k plus 1 is also true. So under the assumption, we assumed what? P of k is true. Now we proved what? P of k plus 1 is also true. Therefore, by principle of mathematical induction, P of n is true for all n belongs to natural numbers. So if you write these two lines, it is better. That's why I told you. Next, 2 power n greater than what? N. I'll check the problem here. Okay, so I will explain here. 2 power n is what? Greater than n. Okay. So prove by mathematical induction that 2 power n is what? Greater than n for all n belongs to capital N. So if you know the idea, you can try independently also. Okay. So let P of n is what? 2 power n. I'll take instead of like this P of n, I'll take what? 2 power n minus n is what? Greater than 0. I'll take this one. For n equal to 1, what is n equal to 1 means? 2 power 1 minus 1. So 2 minus 1. So that is equal to what? 1, which is greater than 0. Okay, so P of 1 is what? Greater than 0. So we verified this statement for n equal to 1. Okay, so P of 1 is what? True. So let us assume that for n equal to k, that is P of k is true. So what is the meaning? P of k true. Here k is what? A positive integer. So what is the meaning that P of k is true means 2 power k minus k is what? Greater than 0. So 2 power k minus k is greater than 0, or you can write what? Is positive. So, okay, so both of them are what? Same. So that's why I'll take 2 power k minus k is equal to m. M is what? M is greater than 0. So here m is greater than 0 and k is what? Greater than 0. Both of them are greater than 0. So k is positive and m is what? Positive. Because here it is told k is a positive integer. Why m is positive? Because 2 power k minus k is what? 2 power k minus 2 power k minus k is greater than 0. So we are taking this is equal to what? 2 power k minus k equal to m. Okay, that's why m is also what? Greater than 0. So both of them are greater than 0. Okay. Now, next step. So now we are going to prove the statement is true for n equal to k plus 1. So P of k plus 1 is also, we need to prove is what? Positive. So now I am going to consider n equal to k plus 1. We put it in P of it. Okay, if n equal to k plus 1 means what? 2 power k plus 1 minus k plus 1. I want to show that that is greater than 0. So now I'm going to consider 2 power k plus 1 minus of k plus 1. Okay, that is equal to what? 2 power k plus 1, you can write what? 2 into 2 power k minus 1. Now 2, what is 2 power k? Okay, 2 power k is what? From equation 1, k plus m. Okay, so k plus m minus k minus 1. So 2k plus 2m minus k minus 1. So this is equal to k plus 2m minus 1. So we know that k is positive and the m is also positive here. Both of them are what? Positive. So, okay, so k is positive, m is positive means totally this is what? At least m is 1, k is 1 means this is totally k plus 2m minus 1 is what? Positive integer. Actually, we need to prove this is what? Positive. That is greater than 0. So therefore we proved the statement is true for what? N equal to k plus 1. So that is, if p of k is true, p of k plus 1 is also what? True. So by mathematical principle of mathematical induction, p of n is what? True. So that is 2 power n minus n is what? Greater than 0. So 2 power n is what? Greater than n, which is true for all n belongs to capital N. Okay. Next problem I'll explain in this PDF. Okay. So show that 4 power n, in the previous problem we discussed, yes. Show that 4 power n is congruent to 3n plus 1 mod 9. So this is a problem. So it is enough to prove that 4 power n minus 3n minus 1 is divisible by 9. Okay, 4 power n minus 3n minus 1 is what? Divisible by 9. Okay, now n equal to 1, what you will get? 4 minus 3 minus 1, which is equal to 0. So 0 is divisible by any number. Okay, so 0 is divisible by 9. Okay. So next, for assume that the statement is true for n equal to k. That means what? 4 power k minus 3k minus 1 is what? Divisible by 9. So it is divisible by 9 means what? 4 power k minus 3k minus 1 is equal to, it is a multiple of 9. So 9 into m. Okay, that is the meaning. Now we are going to prove the statement is true for what? N equal to k plus 1. So n equal to k plus 1 means 4 power k plus 1 minus 3 into k plus 1 minus 1 is equal to 4 into 4 power k. You can write 4 power k plus 1 minus 3k minus 3 minus 1. So now, okay, yes, I splitted 4 into 4 power k like this. Here 4 power k. So actually the idea is I want to write this expression in terms of this expression. That's why I'll write 4 power k minus 3k minus 1. I wrote because I need to use this statement. Okay, this expression. So it's still remaining what? 3 into 4 power k, because we have what? 4 into 4 power k. Okay, already I used minus 3k. I used what? Minus 1. Still we have what? Minus 3. Okay, but by principle of mathematical induction, this is equal to what? 9m. Okay, 9m plus 3 into what? Because 3 is common, 3 into 4 power k minus 1. So 9m plus 3 into, what is 4 power k? Okay, what is 4 power k is equal to what? 9m plus 3k plus 1. Okay, so 4 power k is equal to what? 9m plus 3k plus 1 minus 1 gets cancelled. So that's why I'll get what? 9m plus 3k only I wrote here. And then 9m plus, I'll take again 3 common. So 9 into 3 into 3, 9. 9 into what? 3m plus k. So the left hand side, this is equal to this expression. From this, you can take 9 is common. To take 9 is common, you will get what? 9 into 4m plus k. So 9 into 4m plus k. So what is the left hand side? This is the left hand side. And hence this expression is what? Divisible by 9. Directly you can write. Or this is equivalent to, so we proved the statement is true for what? Okay, you can see the left hand side. Left hand side is what? 4 power k plus 1 minus 3 into k plus 1 minus 1 is equal to 9 into 4m plus k. So that's why this expression is what? Divisible by 9. So we proved the statement is true for n equal to k plus 1. N equal to k plus 1. So that's therefore the statement is true for any n. So 4 power n is what? Congruent to 3n plus 1 mod 9. So that's all the proof. Okay, first I will explain this problem and then I will explain this one. Okay. So next problem, prove that 1 by root 1 plus 1 by root 2 plus dot 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 plus 1 by root n is greater than what? Root n. For n greater than or equal to, they gave what? 2. Because for n equal to 1, this is not true. Because 1, so n equal to 1 means what? 1 by root 1 is 1. That is the left hand side 1. Right hand side is also what? 1. But here strictly greater than. So that's why 1, we cannot say 1 is what? Greater than 1. So there is a reason they will start from where? They, in the statement itself, they gave n is what? Greater than or equal to 2. So now I am going to check n equal to 2. N equal to 2 means some other students, they will write up only what? 1 by root 2. That is wrong. For n equal to 2 means first 2 terms. So what is the first 2 terms? N equal to 2 means first it's not a first 2 terms. It will end up with here what? N equal to 2 means 1 by root 2. Here if I substitute 2 means what? 1 by root 1 plus 1 by root 2. What is meaning of n equal to 3 means 1 by root 1 plus 1 by root 2 plus 1 by root 3. So that is the meaning. Okay, for n equal to 2, this is the left hand side. What is the left hand side? 1 by root 1 plus 1 by root 2. So using calculator, you can check it. This is 1.702, the left hand side. The right hand side is n equal to 2 means it is a root 2. Root 2 is 1.414. So the left hand side is what? Greater than the right hand side. Okay, and hence we proved the statement is true for what? N equal to 2. And assume the statement is true for n equal to k. So you should write assume the statement is true for n equal to k. That means we assumed what? 1 by root 1 plus 1 by root 2 plus dot 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 plus 1 by root k is greater than what? Root k. We assumed. Now we are going to prove the statement is true for n equal to k plus 1. That means 1 by root 1 plus 1 by root 2 plus dot 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 plus 1 by root k plus one more term, 1 by root k plus 1 should be greater than what? Root of k plus 1. I need to show that. So I will take the first k terms here separately because I need to use this idea. So this quantity is what? Greater than root k. So instead of this, I'll replace what? This is greater than what? Root k plus 1 by root of k plus 1. I think here I'll put only for thing fully you should put it like this. Okay, maybe I'll write here. Okay, here it should be okay by mathematical induction. So instead of this quantity, I am replacing by what? Root k plus 1 by this is up here. Okay, here also I will put it like this. So plus 1 by root k plus 1. If I take root of k plus 1 is LCM, then what will get? Root k into what? Root k plus 1 plus 1 by root of k plus 1. Okay. So now from here to here, so we know that k plus 1, okay, k plus 1 is greater than what? K. So this implies root of k plus 1 is greater than what? Root of k plus 1 is greater than root k. So I used here. Where? So here, root of k plus 1, okay, root of k plus 1 is greater than root k. So I used here. Okay, now next. And then plus 1, okay, plus 1 by what? Root of k plus 1. Okay, now if we simplify this, this is what? K plus 1 by root of k plus 1. K plus 1 by root of k plus 1 is what? Root of k plus 1. Actually, we want to show that uh, this one, okay, this expression is what? Is greater than root of k plus 1. So this is a problem. Okay, a problem is over. And then if you want to write one more step, okay, you can write one more step also. So you can see here, actually, yes, it's in this part, actually, you can see here. Actually, I explained this problem, example 2.5 only. Okay, so I proved it is greater than what? Root of k plus 1. And you should say that p of n is true for what? N equal to 2, 3, 4. Because we know that it is not true for what? N equal to 1. Okay. Next problem. Maybe I will explain here. This problem I will explain. Okay. So in this problem, prove by mathematical induction that 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus dot 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 plus 1 by n into n plus 1 is equal to n by n plus 1. Okay. Now I'll take this is actually what? The given problem is Sn. So now I'm going to check it. What is the left hand side here? The left hand side is here. You can what is the left hand side means? N equal to 1. So n equal to 1 means the left hand side of S1, LHS of S1 is equal to 1 by 1 into 2. That is 1 by 2 LHS. What is the right hand side of S1 is what? 1 by 1 plus 2. 1 plus 1, that is also what? 1 by 2. So both the left hand side and right hand side are same. So the basic step S1 is what? True. Now we are assuming the statement is true for what? N equal to k. That means first of k terms what? 1 by 1 into 2 plus 1 by 1 into 2 into 3 up to n equal to k means what? K into k plus 1 is equal to k plus k by k plus 1. I am assuming this is what? Assuming this is what? This is true. This is true. Okay, now I am going to prove that for n equal to k plus 1, that means 1 by 1 into 2 plus 1 by 2 into 3 plus dot 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 plus 1 by k into k plus 1, okay, plus what is the last term? N equal to k plus 1 means 1 by k plus 1 into what? K plus 2, okay, is equal to what I need to prove? I need to prove right hand side is this is equal to I need to prove n plus 1 by n plus 1 is what? N plus 2. That is I want to prove. Okay. Okay. So I'll take the left hand side. So this portion is what? This portion is by mathematical induction k by k plus 1. So now plus 1 by what? K plus 1 into k plus 2. So here in these two terms, what is common? 1 by k plus 1 is common. So I'll take it out. Okay. Or otherwise, first, okay. So first they are taking LCM and then they are taking out. Okay. So if you take LCM, so what you'll get? K plus 1 into what? K plus 2. You take LCM. Okay. And then if you take LCM means K into what? K plus 2. K into K plus 2 plus 1. So now they are writing this one, okay, 1 by k plus 1 into what? K into k plus 2 plus 1 by k plus 2. Okay, so this is same as this expression. Okay, the next step, maybe they will simplify k square plus 2k plus k square plus 2k plus 1. K square plus 2k plus 1. What is k square plus 2k plus 1? K plus 1 whole square. Okay, k square plus 2k plus 1 is what? A plus b whole square. So k plus 1 whole square. This is what? K plus 1 whole square. Okay, this is numerator is k plus 1 whole square. Okay, divided by what? K plus 1 into k plus 2. Divided by k plus 1 into k plus 2. If I cancelling k plus 1 k plus 1, I'll get what? K plus 1 by k plus 2. So that is actually I want to show that. Okay, but okay, sorry. Here I should put what? Mm, yes, n equal to k plus 1. Okay, so k plus 1 by k plus 2. Yes. So I want to show that statement is true for what? N equal to k plus 1. So that means I need to show that what? N equal to k plus 1 divided by what? K plus 1 is what? K plus 2. Okay. Now it is correct. So you can check it. This is equal to the next slide, k plus 1 by k plus 2. So 2 means that sk plus 1 is what? Is also true. Under the assumption sk is what? True. Okay. So that is the inductive step is also what? True. Hence Sn is true for all n belongs to z plus, or you can write instead of z plus, you can write natural numbers. Also you can write. Okay. Next problem. Let's find this one. Okay. So you can see here, use mathematical induction to show that n factorial is greater than or equal to 2 power n minus 1. Okay, this is the problem. Okay, now the statement is Sn. What is Sn? N factorial is greater than or equal to 2 power n minus 1. For what? N equal to what? 1, 2, 3, and so on. Okay, n 2, 3, and so on. It starts from n equal to 1. Okay, now uh, so I already told you what is Sn. Sn is what? N factorial is greater than or equal to 2 power n minus 1. So now we are going to prove the statement is true for what? N equal to 1. So, okay, maybe I'll take a snapshot. So maybe I'll write here a little bit. So n equal to 1 means the left hand side is what? 1 factorial. 1 factorial is equal to 1. What is the right hand side? This is LHS. LHS of Sn. Now RHS of not Sn, LHS of S1. Okay, LHS of S1. Now RHS of S1 is what? Uh, so if we substitute n equal to 1 means 2 power what? 1 minus 1, 2 power 0. 2 power 0 is also what? 1. So left hand side is also 1, right hand side is also 1. So the statement is true. So basic step is true. Now assume the statement, this statement means this statement. Okay, this statement is that is n factor is what? N factor is greater than or equal to 2 power n minus 1. That is the statement. So assume the statement is true for n equal to k. So sk is true. What is sk is true means k factorial is what? Greater than or equal to 2 power k minus 1. Okay, so I am assuming this is also true. Now I am going to prove the statement is true for what? N equal to k plus 1. So to prove k plus 1 factorial is what? Greater than or equal to 2 power so n equal to k plus 1. So the n equal to k plus 1 means what? 2 power k. So actually I need to prove this. So I'll take the left hand side k plus 1 for factorial. This is equal to, you can write k plus 1 into what? K factorial. So we'll keep k plus 1. So k factorial is what? Greater than or equal to 2 power k minus 1. Using this, we are writing k factorial is greater than or equal to 2 power k minus 1. That is what? Using 1. This is actually what? 1. Now, we know that k is what? Minimum value of k is 1. So k plus 1 is what? 2. So k plus 1 is greater than or equal to 2. That's why k plus 1 is greater than or equal to 2 into what? 2 power k minus 1. This is equal to what? 2 power k. So actually, I want to prove what? K plus 1 factorial is what? Greater than or equal to 2 power k. So that is we done it. So steps 2 means what? Sk plus 1 is also true. That is the inductive step is true. Hence Sn is true for all n belongs to capital N. So the set of all natural number, or you can write for n equal to what? 1, 2, 3, and so on. I think example 2.5 already explained. 2.6 I will explain a little bit later. Maybe this is the last problem for today, uh, for this lecture. Remaining problem I will explain in the next lecture. Okay, example 2.7. Okay, maybe I'll take the snapshot. Okay. So this is the problem. Okay. So use mathematical induction to prove that the h2 power n is okay h 2 power n okay is greater than or equal to 1 plus n by 2. I need to prove this. So where hj is equal to what? 1 plus 1 by 2 plus 1 by 3 plus dot 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 plus 1 by j. So this is hj. So for example, hj means it will start from 1 and it will end with what? 1 by j. Okay. Now h2 h2 means what? 1 plus 1 by 2. H3 means what? First, you should understand what is H2 power n. H3 means what? Okay, actually, H3 means from this, what is H3? 1 plus 1 by 2 plus what? 1 by 3. Okay, so suppose if I substitute n equal to 1 means you are getting H2. Substitute n equal to 2 means what? Substitute n equal to 2 means you get what? H2 square. H2 square is what? 4. So that means what? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Okay. Similarly, n equal to 3 means what? N equal to 3 means h2 power 3 is what? 8. So which is start from 1. It will end with 1 by what? 8. Okay. Now I think you understand what is h2 power n. Now we are going to prove h2 power n is greater than or equal to what? 1 plus n by 2. Okay. So let us take Sn is what? h2 power n is greater than or equal to 1 plus n by 2. So the first n equal to 1. Okay, or n equal to 1 means, I already told you, n equal to 1 means what? h2. h2 is what? 1 plus 1 by 2. 1 plus 1 by 2. That is the left hand side. Left hand side of what? This statement. Left hand side of this statement. What is the right hand side? 1 plus n equal to 1 is what? Right hand side is also what? 1 plus 1 plus 1 by 2. This is the left hand side. Okay, from h2 from this definition. Right hand side is what? If I substitute n equal to 1, you will get what? 1 plus 1 by 2. So both of them are equal. So that's why S1 is what? True. The basic step is true. Next, Sk is true. I am assuming that means Sk means n equal to k. So what is n equal to k means h2k is true. So Sk is true means what is the meaning? h2 power k is true. Okay, h2 power k is true. What is h2 power k? From this start from 1 plus 1 by 2 plus 1 by 3 plus so on. Whatever it is here, okay, it should be come here. Okay, so h2 power k means what is the last term in h2 power k? 1 by 2 power k. So this is nothing but what? The whole thing is h2 power k. Okay, so that is greater than or equal to okay 1 plus k by 2. Okay. So this is assumption. Next, maybe I'll explain the next slide. Okay, yeah. Okay. So h2 we proved. Okay, that is n equal to 1. N equal to 1 means what? h2. h2 is equal to what? 1 plus 1 by 2. I already told you in the previous slide. This is the left hand side of okay, h2 means what? 1 plus 1 by 2 by the definition. Which definition? This definition. Okay, h2 means 1 plus 1 by 2. Right hand side is what? 1 plus 1 by 2. So both of them are equal. So next, Sk is true for Sk is true. That means n equal to k is true. N equal to k means h2k is 2 power k is true. h2 power k is true. So what is h2 power k true means? What is h2 power k? Is equal to the whole thing, this one. So 1 plus 1 by 2 plus 1 by 3 up to what? 1 by 2 power k is also what? Greater than or equal to 1 plus k by 2. N equal to k. I am substituting. Okay. So now I am going to prove the statement is true for, okay, I am going to prove the statement is true for in h2 power k plus 1. So that means I need to prove h2 power k plus 1 is greater than or equal to what? 1 plus k plus 1 by 2. N equal to k plus 1. I'm substituting. Okay, what is h2 power k plus 1? h2 power k plus 1 means, okay, so here, okay, what, okay, I will tell you, maybe, okay, I'll explain here first. What is h2? h2 means 1 plus what? 1 by uh, 2. h3 means h not 3 because 2 power 1. Next 2 power 2 because 2 power n. So this is 4 means 1 plus 1 by 2 plus what? 1 by 3 plus 1 by 4. Next h2 power 3 means earlier I told you 1 plus what? 1 by 2 up to what? 1 by 8. So here h2 power k plus 1 means actually 1 plus 1 by 2 plus 1 by 3. The last term should be what? 1 by 2 power k plus 1. But 1 by 2 power k, the next term for 2 power k is not 1 by 2 power k plus 1. Actually, if you want, you can put here what? Dot 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 like this. So 1 plus 1 by 2 plus 1 by 3 plus dot 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 plus 1 by 2 power k and then plus dot 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 plus what? 1 by 2 power k plus 1. Why I am putting here dot dot dot? Because 2 power here what? 2 power 2 square means what? It will end with what? 4. 2 power 3 means what? It will not end with 1 by 5. It will end with what? 1 by 8. Okay, va? So that's why here you should put what? Dot dot dot. Okay. Okay. Otherwise also it's not a problem, but in the next step they are writing clearly. So first, okay, va? These term, okay, they are right. This is equal to, first they will write what? They will split like this, 1 plus 1 by 2 plus 1 by 3 up to what? 1 by 2 power k. So what is the next term? Plus 1 by 2 power k plus 1. Okay, va? For example, here what? 1 h2 power 2 is what? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. h2 power 3 is what? h2 power 3, we are writing 1 plus what? 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. We are adding 1 up to what? 1 by 8. So that's why next term for 1 by 2 power k is what? 1 by 2 power k plus 1. Next term is what? 1 by 2 power k plus 2 plus dot dot dot, and then you should write this term here. Okay, so in between these two terms, so many terms are there. Okay, now next, instead of this, you are using the this okay, by mathematical induction. This is greater than or equal to what? 1 plus k by 2. So instead of this, I will replace what? 1 plus k by 2. The next step from here to here, there is no change here. 1 by 2 power k plus 1, 1 by 2 power k plus 2 plus dot dot dot. This one, what is the denominator? 2 power k plus 1. You can write, okay, you can write 2 power k into what? 2. Okay, okay, 2 power k into 2 power 1. So this is what? 2 times what? 2 power k. Or you can write 2 times 2 power k is what? 2 power k plus what? 2 power k. So these two are same. That's why 2 power k plus 1, we are writing 2 power k plus 2 power k. So why should we write like this? The reason is, suppose if we have 2 power k plus 1, we don't know how many terms in this bracket. Okay, so if you write 2 power k plus 2 power k, now I can tell the total number of terms in this bracket. So first term, this is the first term. This is what? Because this is fixed. This 2 power k is fixed in the first two, the first term. 2 power k is fixed in all the terms in the denominator. So we can count. This is the first term, this is the second term, next to third term. So this is what? 2 power k terms. So now this totally how many terms you have? 2 power k terms. Okay. Total number of term is 2 power k plus 1. Sorry, 2 power k. Total term is what? 2 power k. Okay. Now next okay, maybe I will write something here. Okay, so maybe I will write this is okay, maybe I will can take the snapshot from here. I'll put it here. Just for understanding purpose. Okay. Okay, this is this term. This term I took from where? From this portion. Okay, so this is greater than or equal to, okay, the total term less than or equal to 1 plus k by 2. Okay, so now here plus you can see that out of these 2 power k term, which one is the smallest one? Okay, which one is the smallest one? That means which one is smallest one means which denominator you have the biggest elements you have. This is the term, and the denominator is what? Bigger than the remaining one. So that's why the denominator is bigger. Totally, this is what? Smaller one. So because I'm putting what? Greater than equal to. That's why instead of this, I'm going to replace and replace. What is this actually? This is actually what? 1 by 2 power what? K plus 1. Okay, so we can see here. This is nothing but what? 1 by 2 power k plus 1. Okay. So instead of this, I am going to replace by 2 power k plus 1. So 1 by 2 power k plus 1 is greater than or equal to what? 1 by 2 power k plus 1. So each term I am going to replace by 2 power k plus 1. Okay, 2 power k plus 1. So plus what? 1 by what? 2 power. This is also what? 2 power k. Or suppose if you have a problem, then you can write like this. Okay. So each term I am replacing by this quantity. What is this quantity? 1 by 2 power k plus what? 2 power k, because that is the smallest quantity. This one I am replacing by this one plus 1 by what? 2 power k plus what? Sorry, plus I should put here plus 2 power k. So I am instead of this term, okay, first instead of this term, I am replacing by this because I put what? Greater than equal to this. Similarly, instead of this, this is greater than equal to what? This. And then finally, last term I will keep as it is. 1 by what? 2 power k plus 2 power k. Now we know that this is nothing but what? 2 power k plus 1. Okay, this is nothing but what? 2 power k plus 1. So each term is what? 2 power k plus 1. Totally how many terms I told you just now? Totally 2 power k terms. So totally how many terms? 2 power k terms. So that's why they write, okay, this expression, okay, is greater than or equal to first 1 plus k by 2, they'll keep as it is, plus how many terms here we have? 2 power k. So this is not 2k, this should be what? 2 power k. 2 power k into each one of them is what? Each one of them is what? Okay, 1 by 2 power k plus 1. Okay, so each, the denominator is what? The denominator is 2 power k plus 1. The numerator is what? 1. So that's why they wrote what? 1 by 2 power k plus 1. So totally how many 1 by 2 power k plus 1 here? 2 power k. So that is the idea. So okay. Now from here to here, 1 plus k by 2 plus 2 power k into 1 by 2 power k plus 1. I think here they written rightly 1 by 2. Now if we take 2 is LCM, 1 plus what? K plus 1 by 2. So that is actually we want to show that. So 1 by h2 power k plus 1 is what? Greater than or equal to what? 1 plus k plus 1 by 2. That is, this expression should be greater than or equal to what? 1 plus k plus 1 by 2. So equation 2 means what? Sk plus 1 is true. So that is, the inductive step is true. Therefore, Sn is true for n belongs to Z plus. The crucial step is here. I will explain again. I'll stop here. The crucial step is we should write 2 power k plus 1 is what? 2 power k plus 2 power k. I explained here. 2 power k plus 1 equal to 2 power k into 2, or you can write what? 2 into 2 power k or 2 power k plus 2. First you wrote like this. Next, from using this, we found out totally 2 power k terms here. Okay. Next step, I'm going to replace each term in this bracket by the smallest one. What is the smallest one among this? This is the smallest one among this. Okay, well, so that's why I'll put this is greater than or equal to the last one. Similarly, instead of this is greater than or equal to what? The last expression. So the last one I'll keep as it is. Okay, now what is this totally? This expression is what? 1 by 2 power k plus 1. Similarly, this expression is what? This expression is also 1 by this is what? This is also what? 1 by 2 power k plus 1. So similarly, all of them are what? 1 by 2 power k plus 1. 1 by 2 power k plus 1. So totally how many terms here? Already we know the 2 power k terms. So that's why the previous one. So this expression is greater than or equal to 1 plus k by 2 plus total number of terms is what? Because all the terms are same. Okay, all the terms are what? 1 by 2 power k plus 1. How many 1 by 2 power k plus 1? 2 power k times 1 by 2 power k plus 1. That's all. So which is equal to 1 plus k by 2 plus 2 power k by 2 power k plus 1 is what? 1 by 2, which is equal to 1 plus k plus 1 by 2. That is, we need to show that. Okay, that's all. The remaining problems, maybe I will take one more class on mathematical induction and then I'll try to finish it. Mathematical induction. Okay, thank you.